Now let's look at that third part of that roadmap by mole volume relationship. Now, first of all, we have to know that all this occurs only when there's STP, or standard temperature and pressure. And we'll get much more into this in later chapters. But what you have to know is this occurs at 0 degrees Celsius, 101.3 kilopascals, or 1 atmosphere. Same thing. So this relationship between moles and volume really only will occur in these conditions, because when we're talking about gas pressure, it is dependent on temperature and volume. And so, or I should say, the volume is dependent on the pressure and the temperature of the surroundings. Now the cool thing is that a mole of any gas, doesn't matter what it is, has a volume of 22.4 liters. Now, to imagine 22.4 liters, we have this box here. There's a football, or a football here, European football, American football, and a basketball. This is 22.4 liters, so that's a mole. If we can imagine a gas filling that up, that's a mole. Another one from our book, we know this nice young lady, Sally Jenkins. She's holding a box that is filled with 1 mole of a gas. And again, it could be any gas. It could be hydrogen, helium, carbon dioxide, whatever. So that's a mole of gas. That means it has 6.02 times 10 to the 23rd atoms of that gas. If it's helium, it has 6.02 times 10 to the 23rd atoms of helium. Let's look at this 1 mole of sodium chloride. Okay, if this is sodium chloride, the mass is 58.45 grams. 1 mole of the liquid, which is water, has a mass of 18 grams and occupies 18 milliliters. 1 mole of the gas here has a mass of 32 grams and occupies a balloon whose diameter is 35 centimeters. So that would be oxygen. So this is 1 mole of oxygen gas, 22.4 liters. So back to this, if this would be a pretty big balloon if we filled it up with helium, for instance. If we had a helium balloon for your birthday, say you're going to Chuck E. Cheese, you're turning 16 or 17 or maybe your 18th birthday. You can vote now, so you go out and celebrate at Chuck E. Cheese, and you get 1 mole of balloon. That would be the size of a mole of balloon. And it would be could be any gas. You can tell Chucky, I want a mole of oxygen gas. I want a mole of helium. I want a mole of neon gas. So let's just look at this. If we have this birthday party and each of the guests bring a balloon as a gift, we have Sally over here with a helium balloon, and they're all the same size. If they bring 1 mole of gas, no matter what, it's all the same size. We have helium at 1 mole of 22.4 liters. That 1 mole has the same number of particles as any mole, 6.02 times 10 to the 23rd. Hydrogen has 6.02 times 10 to the 23rd atoms in 1 mole. So notice they all have the same volume. It's 1 mole no matter what the gas. Helium, hydrogen, oxygen, or carbon dioxide, they all contain the same number of particles, 6.02 times 10 to the 23rd. But they have different masses because they're made up of different atoms. Betty is the lightest at 2 grams. So that 1 mole of hydrogen gas will just be 2 grams. Sally Sue with the purple has 4 grams. We get to heavier balloons such as Sally Sue and the red balloon. So the red balloon is the heaviest at 32 grams. And Betty Sue in the orange balloon is the very heaviest at 44 grams. So notice the mole Same volume, same number of particles, but different masses. And if you look at Betty Sue, she was the only one to dress up in a nice dress and high heels. So let's look at our roadmap here. This is volume at standard temperature and pressure. So we could go from the volume of anything to a mole by multiplying it by 1 over 22.4 liters, or we can go from a mole to figure out the volume of any gas. Now this has to be a gas, by multiplying 22.4 over 1 mole. Now this is the easiest because we don't have to multiply it by this or divide by this big number here. We can just multiply or divide by 22.4 liters. Now let's say we have a birthday party at helium balloons, and you tell the Chuck E. Cheese people you want 3 moles of helium balloons, and you can tell them that. I recommend you do. They'll be impressed and may give you extra token for that. Okay, so what is the volume? Or now, we can say what is the liters, because the answer will be in liters. So that's important. It has to be in liters. We must start off or end with liters if we're dealing with volume and moles. So we just say 3 moles of helium, and we look at the conversion factor. There's 22.4 liters of helium per 1 mole of helium. We multiply that across, and I added a couple sig figs just so we can see it. So we have 67.2 liters of helium. If we can imagine 3 of those big boxes that Sally Jenkins was carrying. Okay, let's try another one. Let's say, you know what, I want some just pure oxygen balloons. Just get an oxygen tank, fill it up. And how about, I only want 0.58 moles of oxygen. How many liters would that be? So this is about half a mole, so it's probably half of that box. So let's see if it makes a little, if it come out correctly like that. So 580 moles of O2 over 1, multiplied it by 22.4 liters of O2 over 1 mole of O2. And again, you don't have to have the E there. I just do it by habit. But if you're trying to save ink, especially with these pens, you can leave off the E. So we multiply that across. So we have 12.0 liters of O2, and that makes sense. It's about half of that size. All right, so it's we're just doing dimensional analysis with that conversion factor. Now, if you notice, I could put any gas here. I could put blah, 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 and it's still going to come out the same. We don't care. The cool thing, the very interesting thing is, no matter what the gas is, it's the moles, it takes up that much space. So we have 22.4 liters here. Some molecules will be bigger. Each mole, this is 1 mole of X, 1 mole of Y, and 1 mole of Z. It still takes up 22.4 liters. Doesn't matter what it is. It takes up 22.4 liters. And if it has 1 mole, that means they all have 6.02 times 10 to the 23rd particles. Not matter what it is, at STP, 1 mole will take up 22.4 liters and will have the same exact number of molecules. Now, how about if we go from volume to moles? Let's say we have 12.9 liters of hydrogen gas. How many moles would that be? Okay, we just use our conversion factor, 12.9 liters of H2. So we're going from volume to moles. That's 1. So there's 22.4 liters in 1 mole of H2. And we just divide that out now. So we get 0.576 moles of hydrogen. How about we have 329 liters. We have a lot of liters of gas. How many moles? Well, it's just 329 liters of carbon dioxide. And we are just going to multiply it by 1 mole of CO2 over 22.4 liters of CO2. And we get 14.7 moles of carbon dioxide.